Today, let's talk about Jamba. It's a brand new AI model that's taking a totally different approach to artificial intelligence. It tackles one of the biggest, most nagging problems holding AI back. And, well, the solution is seriously clever. But first, here's a weird question for you. Why is it that the most powerful AIs on the planet have a really, really bad memory? It's a strange paradox, right? These things can write incredible poetry. They can code complex software. But if you have a long conversation with one, it can completely forget what you said at the beginning. So what's going on here? Well, the answer comes down to something pretty simple, but it has enormous consequences. It's a hidden bottleneck, baked right into the way most of these AIs are designed. To really get why Jamba is such a breakthrough, we first have to wrap our heads around this memory problem. And believe me, this is something every single major AI lab is desperately trying to solve. At the very heart of this problem is something with a technical name, the KV cache. Now, don't worry about the name. Just think of it as the AI's short-term memory, its working scratchpad. Every time you say something, it stores key info there to keep track of the conversation. The problem is, when you're dealing with long documents or chats, this cache gets huge. And it gets huge, fast. How huge are we talking? Well, for a model like Llama 2 to process a really long document, its KV cache can demand a mind-boggling 128 gigabytes of super expensive GPU memory. I mean, that's more memory than most high-end gaming computers have in total, just for the AI scratchpad. This right here, this is the bottleneck. So for a long time, AI researchers have had two main ways to build these models, and each one came with a massive trade-off. It's kind of like choosing between two different kinds of genius. Okay, so on one hand, you have the transformers. This is the architecture behind heavy hitters like GPT-4. Think of them as these brilliant but really methodical librarians. They are incredibly powerful, they understand deep, complex connections, but they are slow, and they need a giant desk, that's our KV cache, to lay everything out. On the other hand, you've got a different architecture called Mamba. Think of these as lightning-fast speed readers. They are unbelievably memory efficient and quick, but they sometimes miss the deep nuance and the raw power of that librarian. So for years, you had to choose. Do you want power or do you want efficiency? Until now. The folks who created Jamba over at AI21 Labs basically asked, hey, why do we have to choose? They decided to design a new model that takes advantage of both of these families by combining them. So how did they do it? How did they pull this off? It all comes down to Jamba's totally unique hybrid approach. And this, my friends, is where things get really cool. Yeah, the team at AI21 Labs are the masterminds behind this. And their approach wasn't just to, glue two different models together. No, they created a really sophisticated new recipe for building an AI from the ground up. You can think of Jamba as a dream team of three different powerful ideas. First, it takes the raw analytical power of the transformers. Then it grabs the incredible speed and memory efficiency of Mamba. And then it adds a third ingredient for just massive knowledge, something called mixture of experts, or MO. So here's the secret sauce. For every 8 processing layers inside the model's brain, 7 of them are those super efficient Mamba layers, and only 1 is a powerful memory-guzzling transformer layer. This 7-to-1 ratio is the absolute key. It gives the model just enough of the transformer's raw power to steer the ship, while letting Mamba do all the heavy lifting. That's what keeps the whole system so fast and so lean. So what about that third piece, mixture of experts? Okay, this part is brilliant. Instead of having one giant AI brain that tries to know everything, an MOE model is more like a board of directors with, say, 16 different specialists. Now, for any question you ask it, the model doesn't bother everyone. It intelligently routes your question to only the top 2 most relevant experts on that board. This lets the model have a huge amount of total knowledge, in Jamba's case, 52 billion parameters, but it only uses a tiny fraction of that, about 12 billion, for any single task. It's just wildly efficient. Okay, so that's the theory. It's a very clever architecture, for sure. But what's the payoff? Does it actually work? Well, the results are kind of staggering. Jamba really does give you the best of both worlds. Let's go right back to that memory bottleneck, the KV cache. Remember Llama 2 needing a crazy 128 gigs? Even a more modern expert model like Mixtral needs 32 gigs. And Jamba? A mere 4 gigabytes. That's an 8 times smaller memory footprint than Mixtral. The bottleneck is, well, it's pretty much gone. And what does all that memory saving get you in the real world? Pure, unadulterated speed. When you're processing big documents, Jamba has 3 times the throughput of Mixtral. That means it can read, process, and understand information 3 times faster. This all adds up to a massive practical advantage. On the exact same piece of hardware, a single high-end GPU, you can process a document with 140,000 tokens. That is more than double what a great model like Mixtral can handle on the same machine. This opens up a whole new world of possibilities for people who don't have access to a giant supercomputer. But here's the million-dollar question. Is that huge memory any good? Is it actually useful? Well, there's a classic test for this called needle in a haystack. You hide one tiny specific fact, the needle, inside a massive document, the haystack, and Jamba can find and recall that needle perfectly from a document that's 256,000 tokens long. That's like telling it to find one specific sentence in a 500-page novel, and it nails it every single time. So look, this isn't just a small incremental improvement. Jamba's hybrid design is pointing towards a whole new direction for the entire field of AI. Now, I know what you might be thinking. Okay, they made it super efficient, but did they have to sacrifice quality to get there? And the answer is a resounding no. When you look at the standard academic tests that measure things like reasoning and knowledge, Jamba performs right up there with top-tier models like Mixtral and even the much, much larger Llama 2 70B. It's efficient and it's powerful. So why does all this matter? Because it unlocks a whole new era of applications that were just too clunky or expensive before. I mean, imagine an AI that can analyze the entire text of a huge novel for literary themes in one go. Or an AI that can read a 300-page legal contract in seconds and find the risky clauses. Or one that can process a patient's full medical history to spot patterns a doctor might miss. This is the kind of stuff that's now on the table. Jamba isn't just a new model. It's really a proof of concept. It shows all of us that we don't have to keep choosing between power and efficiency. We can, in fact, have both. It proves that a whole new kind of AI is possible. So the only real question left is, what are we going to build with it?